In this video, let's go ahead and derive the derivative of this given trig function of sine of x over cosine of x. Now, ultimately, you really want to know that this sine of x over cosine of x can also just be rewritten as tangent of x. So something that you just want to kind of memorize in the future is that if you have the derivative of tangent of x, this is going to be just equal to secant squared of x. Alright, so that is a bit of a spoiler, but this secant squared of x is the derivative of this sine of x over cosine of x. Now, while that's the short and easy answer, let's talk about why that's going to happen using the quotient rule here. Notice that our expression is a quotient. We have a function of sine of x and we're dividing it by the function of cosine of x. So we are finding the quotient of two functions here. Let's remember the quotient rule. The quotient rule states that if you're going to take the derivative of the quotient of two functions like f of x over g of x, you're going to take the derivative of f of x, multiply it by just the regular g of x function, take away the derivative of the g of x function multiplied by the original f of x function, and that whole thing is going to be on top of the g of x function squared. Now notice our f of x function in this particular case is going to be the sine of x. So we can just go ahead and write that f of x equals sine of x. And also notice that this g of x is going to be what our cosine of x is in this particular case. So let's go ahead and write that down. So we know what f of x and g of x are equal to. What is the derivative of f of x though? Well, hopefully we can know or remember that the derivative of sine of x is going to be cosine of x. And then on that same note, we also want to know the basic derivative of this cosine of x. So the derivative of cosine of x is negative sine of x. So those are two that you're definitely going to want to try to remember. Alright, so once we've identified each of these pieces, we're actually just going to do some substitution. So this f prime of x, or the derivative of f of x, is going to be cosine of x. This g of x is going to be this cosine of x. G prime of x is going to be negative sine of x. F of x is going to be this sine of x. And this g of x, again, is going to be this cosine squared of x. So let's go ahead and make some substitutions. So here's what our derivative is going to look like when we go ahead and substitute in the functions that we have and their derivatives. Now let's go ahead and simplify this a bit here. Alright, so starting off, let's go ahead and simplify this cosine of x times cosine of x right over here. That's just going to be this cosine squared of x. So I'm going to go write that as cosine squared of x. That's cosine of x times cosine of x. Then we're going to take away what next here? Well, we have this negative sine of x multiplied by sine of x. So that's just going to be a negative sine squared of x. So far that's just going to be it for the numerator on the bottom. Instead of writing this cosine of x squared like this, let's go ahead and move that little exponent to where we typically put it. I know it's a little strange, but we put it right over there so it's a little less confusing. That's typically how we're going to write it. And then on the top here, notice how we're just taking away a negative here. So I think we can go ahead and rewrite that as a sum, right? So taking away a negative is just adding a positive. So we're going to write cosine squared of x plus this sine squared of x. Again, this whole thing is just going to be on top of this cosine squared of x. Alright, at this point, you want to try to remember one of your trig identities. That sine squared of x plus cosine squared of x is equal to 1. Now, since sine squared of x plus cosine squared of x is the same thing as cosine squared of x plus sine squared of x, we can go ahead and swap out this cosine squared of x plus sine squared of x for this 1 here. Doing that, we can just go ahead and rewrite the numerator as 1, and the denominator is going to stay as this cosine squared of x. Now, another thing to remember about one of your basic trig identities is that when you see the reciprocal of cosine of x, or 1 over cosine of x, that's equal to secant of x, right? Now, if that's the case, then you also want to remember that 1 over cosine squared of x is just going to be equal to secant squared of x. Alright, so using that information, we can go ahead and take this expression, and instead of writing this 1 over cosine squared of x, we're just going to go ahead and write secant squared of x. So that whole entire thing is going to simplify down to just being secant squared of x. So going back to the beginning here, let's see what we were going to start by just trying to remember or memorize. We said from the very beginning that the derivative of this sine of x over cosine of x, aka this tangent of x, was going to be this secant squared of x. Again, if you can just memorize that, I think that would be great. But why does that work? Well, if you've learned the quotient rule and we apply our quotient rule to it, this is kind of the proof or all the work behind where it kind of comes from. Then you can eventually just memorize it, but you can use the quotient rule to find it out. So long story short, this is the derivative of the original function of this sine of x over cosine of x, right? Now you can just memorize in the future that this sine of x over cosine of x is this tangent of x, and that's going to just be this secant squared of x, so you just make those substitutions. But if you just wanted to know where it comes from and maybe why you need that quotient rule, this is all the kind of messy work that kind of goes behind the scenes that lets you just memorize that derivative. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing this with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.